right, our last video in 10.3, we're going to be multiplying and simplifying radicals. Now, if your radicals don't break down evenly right away, it might be easier to first multiply them, if you can, then simplify them. For example, look at example number 5a. It asks us to multiply and simplify. The square root of 2 times the square root of 6. Well, there is no whole even square root of 2, and there is no even square root of 6. And I can't even break any of those down and find groups of 2. But what I can do, because they're both the same radical, is I can combine them. So the square root of 2 times the square root of 6, I can really say is the same thing as the square root of 12, right? Then I can take the square root of 12 and try to break it down, since there is no even square root of 12 either. I know that 12 breaks down into the square root of 4 times the square root of 3. Or I could say 2 times 6, and then I can break down 6 into 2 times 3. And then I can look for groups of 2. It looks like I have a group of 2 here. Those 2's can come out, and then the 3 would be a lonely 3 that stays inside. But now I can say that the square root of 2 times the square root of 6, or the square root of 12, is the same thing as 2 times the square root of 3. Let's do another one. Look at b. If I have the cube root of 2, I know there's no cube root of 2, and I can't break that down any farther, times the cube root of 4. Well, I can break down the cube root of 4 into 2 times 2, but because it's a cube root, there's not enough 2's to come out. So I'm stuck. What I could do, though, instead of looking at them as 2 separate cube roots, because they're underneath a cube root, I can combine them into one. I can say that I have the cube root of 2 times the cube root of 4, which is the same thing, really, as the cube root of 8. Oh, wait a second. Isn't there a cube root of 8? 2 times 2 times 2 is 8. So I can really say that my final answer is just 2, because the cube root of 8 is 2. All right, let's look at c. c has a whole bunch of different variables with different exponents. There's a whole bunch of stuff going on, but what I do notice is that they're both underneath a cube root. You could try to simplify them first. It might be easier, though, to combine them and then simplify them. So instead of 2 separate cube roots, I can combine them into one. I can really say, if I have an x squared times an x squared, that I really have the cube root of an x to the 4th. And if I have a y to the 4th times a y to the 6th, I really have y to the 10th. Now I have the cube root of x to the 4th times y to the 10th, and then I can see if I can break it down or simplify any farther. I noticed here that I have 4 x's. I'm looking for groups of 3, and so I can take out one group, and then I would have a lonely one left inside. I have 10 y's, so if I'm looking for groups of 3, that's 3 groups that can come outside, and then one lonely y on the inside. So I can really say that I have x, y cubed, times the cube root of xy. Last one here, let's look at d. I have the 5th root of a cubed times a b minus c to the 4th power, times the 5th root of a to the 7th times b minus c to the 4th power. I notice I have some of the same stuff underneath each 5th root, so what I can do is combine them into the same 5th root by taking my like bases and combining them. I have a to the 3rd times a to the 7th, which is really a to the 10th. I have a b minus c to the 4th and another b minus c to the 4th, so I really have b minus c to the 8th. They're both underneath a 5th root, so let's look for groups of 5. For my a to the 10th, I can actually take out 2 groups of 5 evenly, right, with no lonely ones left inside. And if I have 8 of these b minus c groups, then I can take out one group and I would have 3 lonelies inside. So I would have an a squared, I would have a b minus c on the outside, times the 5th root of b minus c. And remember, there's 3 of those left inside, so I'm going to say cubed. It might be easier to take your radicals, combine them first, and then simplify them. As long as they're underneath the same radical, you can do that.